Good afternoon, everyone, and welcome to How to Design and Deliver Effective Math Intervention. This webinar is a special collaboration between the Council for Exceptional Children and the National Center for Special Education Research. We'll begin the presentation in just a moment. My name is Megan Shea. I'm on the staff of the Council for Exceptional Children, and I'll be moderating today's webinar. I'd like to introduce the Commissioner of the National Center for Special Education Research, Joan McLaughlin. Joan, would you like to say a few words?
Yes, thanks, Megan. Hi, everyone. I'm so glad you could join us today. The Institute of Education Sciences National Center for Special Education Research, or NICSR as we call it, funds research to understand and better support children and youth with disabilities so that they can be ready for and succeed in school. We're trying to do a better job getting the results of research into the hands of those that can use it, to the teachers and service providers who work every day to make a difference. We appreciate our collaboration with CEC on this webinar, and I want to particularly thank Dr. Powell for her commitment to making research used and useful. Please provide feedback to CEC so that we can assess how this goes, and if it works, hopefully we can continue our collaboration. Thanks so much.
Thanks, Joan. Responses, and let me go ahead and turn this over to Sarah.
All right, thank you so much, Megan. Hi, all. Let me get my computer there. All right. So welcome to this webinar. Today we are going to discuss how to design and deliver effective math intervention. My name is Sarah Powell, as introduced, and I am an associate professor at the University of Texas at Austin. I work in the Department of Special Education, and my primary focus is conducting research to figure out what are the best ways to provide mathematics instruction to students in both general education classroom settings and special education settings. And so if you want this presentation that we're reviewing here today, I did place it on my website. You can go to the website and click on presentations and download this presentation. I'm hopeful that you will share it with others. And if you have questions or comments, please feel free to email me and also find me on Twitter. I tweet a lot about different math things, and I'd love to share those with you. So just a little bit about myself. I am a former kindergarten teacher. This is me almost 20 years ago. And then I figured out that I left the classroom because I was really interested in figuring out what are some of the evidence-based practices that are best for teaching mathematics, and how can we help lots of teachers, not just myself, but a lot of other teachers use those practices. And so in my current job, I get to work on a lot of great projects funded by some of these organizations. And so a lot of the information that I'll talk about today comes from things that I have learned in my own research, as well as the research of others. Now, our focus today is on mathematics, and specifically on mathematics intervention. And when we think about mathematics intervention, we may be working with a number of different groups of students. There's lots of different names here. Perhaps some of these students actually have an identified specific learning disability and IEP goals in mathematics. But a lot of students that require mathematics intervention don't have a disability identification. We might call those students students that experience mathematics difficulties, students that are at risk, students that are experiencing difficulty, students that fall below, basic performance thresholds. And so everything that we are going to talk about today really fits for all of the students that are listed on this page. So many of these students would receive their mathematics instruction in the general education classroom, whereas other students might receive their mathematics instruction in special education settings, either push-in settings in the general education classroom or pull-out settings where they would be more in a resource room or a self-contained setting. And so I'm going to keep this as broad as possible, but knowing that this webinar is really not just meant for students that experience a disability in the area of mathematics, but it's really for students that experience difficulty in mathematics. So we're going to talk through evidence-based practices today that are important to include in your math intervention. And this evidence-based practice, this is an umbrella term, hence there's an umbrella here on the slide. And so this may encompass evidence-based interventions. So these may be packaged interventions that we either purchase and they're paper-based or technology-based, and we use this packaged intervention to improve the mathematics outcomes for students. An evidence-based practice might also not be a packaged intervention, but just an evidence-based strategy. A very popular strategy, which we will talk about today, is the use of concrete manipulatives. So that's not something packaged that you buy, but it's just something that we can pull in and use when necessary. And we may also rely on things that show promise. They are promising practices, but nothing that we will talk about today has no evidence or negative evidence. And when it comes to providing mathematics intervention for students that do experience math difficulty, we really want to rely on evidence-based practices and not things that we want or hope will work, but things that we know work. And so I'm putting things together today in this session, thinking about evidence-based practices. And so I really relied on some of the resources that come from the Institute of Education Sciences, specifically the What Works Clearinghouse practice guides. On the left-hand side here, you can see is the practice guide about assisting students that experience difficulty with mathematics. That practice guide came out 10 years ago, and so they are currently revising this, which I'm very excited about. So coming very soon will be a revised practice guide about assisting students who experience mathematics. And in some conversations with the people that are doing that work, almost everything is the same from the original practice guide. One of the new things that they're bringing in is a focus on math language, which we are going to talk about today. And so the things that we will talk about today will really focus on these 5 components from the What Works Clearinghouse practice guide that showed either moderate or strong evidence. So we're going to talk about a little bit about screening students and having a framework in place to provide mathematics intervention support to students that require it. We'll talk about explicit instruction. We'll talk about word problem solving. We'll talk about the use of multiple representations and building fluency. Each of these has an evidence base, which is why we are going to focus on them today. So speaking of the framework, when we want to provide math intervention, we need to think about, well, how are we going to provide this math intervention? What is the framework that we are going to use for the intervention? So I like to rely on this framework. This comes from the National Center on Intensive Intervention. And this framework starts with a validated instructional platform. That's where we're going to focus most of our efforts today. But once that platform is in place, we do need to make sure that we progress monitor to determine whether this is adequate for students or inadequate. If students are not making adequate response, kind of move down here on our framework to the middle, so we would conduct a diagnostic, then make adaptations to that instructional platform, and then continue to progress monitor to find a really good intervention fit for the students. So I'm not going to focus on this framework today, but if you do want more information, I would suggest visiting intensiveintervention.org. Now we're going to think about the math pathways that our students are on, and when we want to bring in this intervention platform that we just talked about. So I want you to imagine that this line here is just a pathway that any student that you work with is on in terms of their mathematics learning. And here's where you want your student to be. All right, you might imagine this is 2nd grade, or maybe some of you are imagining that's a 9th grader. But often, and you're probably here for this webinar today because this is where your student is on their pathway of mathematics learning. And so that's where we bring in this framework for providing strong instruction paired with progress monitoring to then hopefully move students along in terms of their mathematics outcomes, or giving them more mathematics knowledge so that their mathematics outcomes improve. So today we're going to talk about 2 things. The first here is design. So how do I design a strong math intervention for my students? And I'm not going to spend a lot of time on this, but I am going to give you some ideas for how you could do this with your students. So the first thing when we think about design, excuse me, when we think about design is going back to that math pathway. So let's say you have a student that experiences difficulty in the area of place value. So you first want to think about, well, what is the pathway that is important for students to learn in terms of place value? So we might say that first students need to compose and decompose numbers up to 19. and do this learning around tens and ones, and then hundreds, tens and ones. Then students start to round to tens and hundreds. Then students start to look at multi-digit numbers and like really start to understand the place value. And then finally translate that place value knowledge to knowledge around decimals. So this is the pathway that a student follows to develop a strong understanding related to decimals. Here's another pathway that's a little bit longer. This one is related to not place value, this one's related to problem solving. So first students start solving addition and subtraction word problems within 10, and then they do that within 20, and then within 100. Then we start to work on word problems related to multiplication and division. Then we work on word problems with all 4 operations. Now we start to work on word problems with fractions. Then we start to work on word problems with all kinds of rational numbers. And then finally, we get to thinking about word problems with variables. So this is the word problem pathway that students are on. And I have to understand this pathway in order to figure out what content is important to put into the math intervention. So let's say this is where we want our student to be, but this is about where our student is. And so now we're going to then figure out, well, what is the essential math content that fits between the red arrow and the green arrow? So kind of keep your eyes on the turquoise standard and the red standard. I'm going to now spread those out a little bit more. And I'm not just going to think about problem solving. I can't just teach problem solving without thinking about standards related to understanding concepts, standards related to place value, and standards perhaps related to fluency or computation. So I look at the standards. Perhaps you look at your state standards, or maybe you look at your district scope and sequences. There's lots of resources where you can find this information. And now I'm going to fill those in. And so I want to get my student to the place where the green arrow is, but they are over here on the red arrow on their pathway. And so now everything that falls in between the red arrow and the green arrow, that's going to be the focus of the content of the math intervention. So before you say, oh, well, which package do I need to buy, or which intervention is the best to use, we really need to be reflective about what a single student, maybe what a group of students, or maybe even a classroom of students need to work on. Many times the students that are experiencing difficulty with math, they have some foundational gaps in their mathematics knowledge. And so we need to think about their pathway. This pathway may look different for every student that you work with, because some students may have strengths in place value. Some students may need more place value support. And so you have to do this for every individual student or every group of students, so that then you can think, okay, well, what intervention or what evidence-based strategies are going to be the best to teach this math content? So when we're thinking about designing intervention, the first step is to really evaluate the strengths of your students, and then what foundational knowledge they need to work on, and then place those on a math pathway to figure out what's the best pathway for the students that you want to work with. Now, a few resources that I will often use to put together some of these pathways. I like this. This is from the Achieve the Core. I like how they've laid this out. These are progressions that lead to middle school algebra. I think that this is really helpful to focus on what's essential for students to know and what's essential for us to include in math intervention. I also like a lot of the information from the National Council of Teachers of Mathematics. These are the curriculum focal points. Here you can see, for example, in 3rd grade, they say that students really need to have a strong understanding of multiplication, division, fractions, and two-dimensional shapes. And so when I'm thinking about designing the content for perhaps a 3rd grader who is experiencing some difficulty with math, I may want to start there. And I can also use these focal points. Maybe I have a 5th grader who is showing that they are struggling with some early multiplication and division concepts. I may go back to some of these 3rd grade focal points and make sure that they have a concrete understanding of those before I move on to 4th grade material and then subsequently 5th grade material. So I like these focal points as well. There are a lot of other resources out there, so those are just some of the 2 that I rely on. But often when I work with teachers on thinking about designing the math intervention, we look at your state standards and we like cut them apart. And you're not just looking at state standards in one grade level, but across grade levels, because often we need to go back a little bit and pick up some things where students had holes in their math understanding so that we can move them forward to that green arrow where we would like the student to be. So in terms of the design of the instruction, it's really thinking about, well, what content is essential for us to focus on? And then we'll spend the rest of our webinar thinking about the delivery, or how do we deliver strong math intervention to students? So I'm going to go back to this framework that comes from the National Center for Intensive Intervention. And I want to think about what should go into a student's instructional platform. This is really the jumping off point for developing a math intervention program for students. And so we're going to talk about 5 things today, each of which has an evidence base, as it is important to focus on when we're thinking about teaching students that experience difficulty with math. So we'll talk about 3 things related to how we deliver this instruction. We'll first review explicit instruction. We'll talk about the use of precise language, especially embedded within explicit instruction. And then it's also important to bring in multiple representations to help students really see and understand math in different ways. And then there's 2 strategies that the evidence tells us are really important to include for students that experience difficulty with math. The first is thinking about building fluency. This is an area where a lot of students do experience difficulty, and just a little fluency building can help students improve their mathematics knowledge quite a bit and give them a lot of confidence around mathematics. And the other will be problem-solving instruction. And this webinar is meant to be a brief overview, so I'm not going to dig into any of these 5 components very deeply, but I'll review them all so that you can start to think about, am I including all of these in my math intervention that I am designing? Or am I observing these when I'm watching other teachers teach students that experience difficulty with math? So we'll kick off thinking about our instructional platform with a brief review about explicit instruction. So this is a model of explicit instruction. This too comes from the National Center on Intensive Intervention. They have a really nice set of modules designed by Devin Kearns at the University of Connecticut that are focused on explicit instruction. And they are not math specific, they are very general, but it's a very nice review of explicit instruction if you'd ever like to think about accessing those resources. But when we see explicit instruction in mathematics, it's a strong combination of modeling and practice. So I'll talk about each of those things separately, but I want to go ahead and have you look at the slide and see this blue rectangle and notice how this is under both modeling and practice. So I'll come back to that in a few minutes, but I want to emphasize that those supports, that's really what makes explicit instruction work. And so we have to incorporate those in both modeling and practice. But when we think about modeling, modeling starts off with a goal and why this math is important. And here are a few examples if you'd like to read those. We follow that goal by a modeling of steps. This is a pretty simplified example of how I could add 2-digit numbers using a partial sums strategy. Most modeling isn't just going to fit on 7 or 8 lines of text. I use this one because it fits on this slide. But you're going to model steps and help students see, well, how could I solve this problem using this specific strategy? But as we look at the dialogue here, I'll start off, just read this, to solve 26 plus 79, I first have to decide about the operation. Am I going to add, subtract, multiply, or divide? So automatically a question posed to the student or students that we're working with. The students provide an answer, and then we confirm that. You're right, the plus sign tells me to add, so I'm going to add this. And then very soon after, okay, what's 20 plus 70? So it's a question posed to the students, and the students are going to respond to the teacher. Then I say, okay, where are we going to write the 90? That's another question posed to the students. And so when we think about modeling, it needs to be a dialogue between the teacher and the students. And sometimes I kind of want to call modeling dialoguing. It's a go back and forth. The teacher is the leader here, but it's a discussion, it's a dialogue between the teacher and the student. With the modeling of the steps, we need to be really thoughtful about, well, what examples do we want to provide? In math, you have to really think through, well, how do I want to present the mathematics that students are going to work on? So for example, if we were working on division today, how is it going to be presented? Are you going to present it all three ways that are shown on this slide? Or are you going to present it one way? What is most important for your students to get out of this lesson of division? And also in modeling, this is a really opportune time to bring in non-examples. So if I was teaching a lesson on division, maybe my first problem that I work on with the students is 32 divided by 8, and then we do 42 divided by 7, and then we get to the third problem here. And the third problem is 25 minus 5. I might anticipate as a teacher that a lot of students would answer this as 5, thinking they're just dividing today and that's all they're doing. But we want to bring in non-examples so that students know when to apply their division strategy and when to not apply. And probably many of you are already familiar with this information, but really the most common mistake that students make in math in the elementary grades is that they don't look at the operation and they don't do what the operator symbol tells us to do. So that's when we see students multiplying when they were supposed to add. We see students subtracting when they were supposed to divide. So if in modeling, we can have discussions, well, oh yeah, that's right. That's not the division symbol, that's the minus sign. What does the minus sign tell us to do? Those are good things to bring in during the modeling of explicit instruction. So then as we move forward, we kind of do our modeling, then we move to practice. And practice is really where students learn mathematics. You might be an amazing modeler and you're doing these dialogues with students, but until students are actually doing the mathematics with you, the learning isn't going to be as strong as it could be once practice comes into play. And in practice, we see different kinds of practice are important for students, especially as we think about scaffolding mathematics instruction. So here with practice, we want to make sure that students are engaged in guided practice. So here the teacher and students are practicing together. We do this where a tutor might be doing a problem on a whiteboard. The students are doing a problem on the whiteboard. Maybe you, the teacher, are showing how to show a fraction with fraction tiles. Maybe, and then the students are working on the same problem and also using their fraction tiles. Maybe you have a student workbook and you're working a problem in it and talking with the students. They're working on the same problem at the same time. Guided practice is one of the types of practice where we really see that students ask a lot of questions, they get a lot of feedback. If you just do modeling and then you skip to what we call independent practice, where students are practicing on their own, students aren't getting the support that they need to really become more proficient with the mathematics to then be able to work on the math independently. So practice involves guided practice and independent practice, where students then start to have less support from the teacher and are starting to work on these problems on their own. And then, as I said before, remember, pay attention to that blue rectangle there. During both modeling and practice, we need to bring in a few different supports. And this is really where that dialogue and discussion occurs, is through these supports. So we need to make sure that we are asking a lot of questions to students and a mix of questions. So a mix of lower level questions, such as some of those at the top of the slide, and higher level questions. Those are often our why or how or can you explain this again? Higher level questions so that we can get at student thinking. It doesn't have to be 50% low level and 50% high level. In fact, I think more often it's probably, 70% low level questions and about 30% high level questions. But if you only asked 100% low level questions, then you're never really going to engage students in the mathematics reasoning that they should be involved in. And if you only ask high level questions, you're probably going to get your students a little more anxious than they should be. So low level questions build confidence, where high level questions really get you to understand what the students understand and then where they might need more instruction. We should ask those questions frequently. When we design math intervention for modeling and guided practice, our kind of typical rule of thumb is that students respond every 30 to 60 seconds. And that's kind of like the minimum. If they respond more frequently, that's awesome. But by asking students to frequently respond, students are kind of have to pay attention more, and they have to focus, and they have to be involved in the lesson. If 60 seconds goes by and you haven't asked the students to do something, you're likely losing their attention. And if students aren't paying attention, they are not learning mathematics. So these frequent responses, they can be oral. You can ask class-wide questions or individual questions. Maybe you ask students to work on something with their partner. Maybe students write something. Maybe they show something with manipulatives. Maybe they give you a thumbs up, thumbs down. Maybe they draw something. There's many ways to respond. They don't have to be oral, but if you're continually asking students to do those responses, and then those responses give you an idea of how well the students are learning the math, and that kind of then segues into this feedback piece. So as students provide, you ask questions and then you get students to respond, we need to make sure that we're providing immediate feedback to these students. So affirmative feedback, students do something that's really great, affirm that, and what about it is so awesome. So here in our example, that was awesome how you used your word problem attack strategy. So confirmation that that's a great thing to do when solving word problems. And then corrective feedback. So it might be like, well, tell me how you did this. Let's look at that again. Let's talk through this together. So really getting students to voice what they were trying to do in the problem so that we can figure out what was the point where there was a misconception or misunderstanding, and we can correct that. And then we also need to make sure that we move these lessons along at a brisk pace. For students that are receiving math intervention from you, these are students that need the most math practice of any student that you likely work with. So you better be planned and organized and ready to go. And the best example I have of this is do all your whiteboard markers work? I was in a classroom pretty recently where a teacher spent about 4 minutes finding markers that worked. And so that was 4 minutes out of 25 that were wasted, where the students could have been working on math, but were not. So be planned and organized with your materials and be ready to go. Now, as we think about our explicit instruction here, I kind of described it as this really nice 50-50 relationship. Oh, it's half modeling and half practice, but it's never that, that clean. If you're introducing something new, you might do a lot of modeling and a little bit of practice. But remember, you're always asking good questions, getting students to frequently respond, and you're providing feedback. Once the students have learned something, you might kick off with a little bit of modeling and then a whole lot of practice. And then you're still asking those right questions, getting students to frequently respond, and providing feedback to those responses. So explicit instruction has to be flexible. One day it might look like the model here on the left, the other day it might be on the right. And it's really going to depend upon your students and where they are acquiring knowledge related to the mathematics skill that you are working on. So we covered explicit instruction, and now on top of that, I want to layer precise language. So there is a tremendous amount of language that we ask students to think about in the world of mathematics. So some colleagues and I looked at several mathematics textbooks, and we flipped to the back and we looked at the glossaries in those textbooks, and we made note of all the different terms that are in those glossaries, and then we eliminated all the duplicates, and we came up with this graph that you see here. And so in kindergarten, first and second grade glossaries, the vocabulary expectations in mathematics for students range from anywhere from about 100 to 130 different terms. Even in kindergarten, there's a tremendous amount of language that students have to understand in order to fully participate in the mathematics classroom. In third grade, we see a huge jump up. Probably most of you are thinking about multiplication, division, and fractions, which are usually introduced in the third grade year. And so we see over 300 terms in third, fourth, and fifth grade glossaries. And then in middle school, we see another jump up over to anywhere from 400 to 500 different terms that students are responsible for across the grade levels. And if any of you are wondering that if all the terms accrued across grades, they did not. Our final database had over 1,200 different mathematics vocabulary terms that students might see sometime in their school career from kindergarten to 8th grade. And this is important because how students learn math is through the language of math. So students might listen to math from maybe a partner's talking about math, maybe their teacher's talking about math, maybe they're watching a video that's talking about math. We ask students to engage in discourse about math. So students have to speak within the language of math. Many times students have to read within the language of math if they're reading online resources, if they're reading textbooks, if they're reading word problems on a test. And in some cases, students are expected to write about math. And all of that involves an understanding of mathematics vocabulary. So as teachers, as we design our math intervention and we start off thinking about, well, how do we use explicit instruction? This vocabulary piece is really essential to think about because it's how you are talking about math, how they are talking about math, how they are reading about math. And so we need to provide some explicit instruction on the vocabulary of math. And math vocabulary is tricky for a lot of students. This slide here that I'm going to show, this comes from one of my favorite articles from 2002 by Rubenstein and Thompson about why do students experience difficulty with the vocabulary of math. And they point out that there are math terms that may also be featured in what we would think about as like general English, but they have different meanings. So if I'm thinking about base in math, that's different than if I'm thinking about, touching a base when I'm running the bases, playing baseball. There are math terms that are shared with English, but then there's similar meanings. So I may ask about what's the difference between summer and winter. That's a slightly less precise meaning than what is the difference between 9 and 5. There are a lot of math terms that are only used in math. And so we have to imagine that when students come to us, to the math classroom, they've likely never heard these terms before. So they do require explicit instruction and lots of practice to learn these new terms. And then there's some math terms that have more than one meaning. So if I'm thinking about square, am I talking about square as a two-dimensional shape, or am I thinking about squaring a number? Same thing with round, second, and here base. So you can actually see some of these words fall into multiple categories. There are some math terms that students may have heard in another class that's another content area of class, so maybe in science or social studies. There are some math terms that are homographs, so especially as we think about how we speak these terms, if I say that I want you to find the sum, do students think that I'm adding two numbers together, or do students think that you want me to find sum of something? And this is really important for students with math difficulty who also may have language impairments or reading difficulty, or students that are dual language learners. There are some math terms that are related but do have very distinct meanings that may not always come across to students, especially if I say hundreds versus hundredths. There's not a huge difference in how those sound, but there is a huge difference in what those mean. So do students understand the distinct meanings of those terms? For some students that where they are dual language students, they may have words in their home language that have different meanings in math. So we have to think about those. We have things that are spelled irregularly, and so are students aware that these terms are related to one another, even though the base doesn't seem to be spelled the same way. How do we think about math? We talk about math in many different ways, and then we may use a lot of informal terms subbed for formal math terms. So what I think about this whole list here is that this is where I have to think about my explicit instruction. So in my explanations, in my examples, in the guided practice, in the questions, and in my responses, are we helping students learn the vocabulary of mathematics because it is so complex? And what are the opportunities that we are embedding within our explicit instruction to explicitly teach the vocabulary of math? So just a few examples. This is a set of articles that some colleagues, Elizabeth Stevens and Elizabeth Hughes and I wrote over the last 2 years. And I'm happy to share these with you if you'd like them. But we gave some examples of like, it's not a quick fix, but what are some things that you can do tomorrow to think about this math language piece? So here, the red person, they're kind of giving us an informal example of math vocabulary. So they say, oh, and the last one's 10. That actually came from a counting song that we saw used in a classroom. The green person is kind of maybe using math language a little bit better. We could say 8, 9, 10. We're not going to indicate that there is any last number, and we'd say, oh, we'll stop counting there today, but we could count more. Some other examples, instead of asking what number is in the tens place, that's not really correct. What digit is in the tens place would be a better way to say that. Instead of saying the alligator eats the bigger number, I hope that a lot of you groaned out loud when you saw that example. We could be talking about is less than or is greater than. Instead of carry or borrow, which are really procedural terms, we could get more conceptual by talking about trading, exchanging, or regrouping. Top number, bottom number, that's kind of how a lot of people will talk about fractions, but those are our numerators and denominators. We don't want to ask students to reduce fractions. That would indicate that the value of the fraction may change. Maybe we ask students to rename or simplify. And how we read decimals, we might be able to do better at that tomorrow. How we think about things related to geometry, that isn't a point, that's the vertex. And then these are some of the language things that we may want to think about around transformations. But really, when I think about language, I think about helping students use the formal math language. Many times students have a lot of informal math language, and we may think like, well, that's okay, they're just learning right now. But when students read about math, when they answer test questions, especially about math, it's all through the formal language of math. And so as a teacher, making sure that we're using the formal math language so that we are giving students, good examples to go by, and we are asking students to use the formal language of math. So this is as students engage in discussion with you or with peers, what kind of language are students using? And then using these terms precisely, making sure that we aren't thinking that factor and multiple mean the same thing. Then as we come back to our instructional platform, then we want to layer on top of this idea of using multiple representations. So with multiple representations, a lot of people will refer to this as the concrete, representational, abstract. I kind of get tricked up on that word representational because all of these are representations. So I like to think about this as the concrete, pictorial, abstract, or just using the term multiple representations. And when we think about this, we've got concrete three-dimensional objects. Here are just a few examples that students can move around to show different concepts and procedures. We have pictorial images. These are two-dimensional, so I might see these on a screen like we're looking at here. Might see these in a workbook, on a worksheet, on a test. And we also have a lot of two-dimensional pictorial images that are here that are found online through technology. So here we have examples of algebra tiles that can be on an iPad. We have examples of Cuisenaire rods, an example of a digital geoboard. So these are still two-dimensional. Students are touching and moving them around, but these pictorial technology tools can help students also understand the math concepts and procedures. As then we also focus on the abstract, which are the numerals and symbols. I would add to that the words of mathematics as well. Now, when we think about the concrete, the pictorial, and the abstract, I like this image here. They are overlapping. When we have designed our interventions in 3rd grade and in middle school, if I'm doing something with hands-on tools, I always have the abstract form of the problem present. Same thing, if I'm asking students to draw, maybe I'm asking students to draw place value or draw a fraction, I also always have the abstract form of the problem present. So this isn't like do one and then do the other and then finally get to the abstract. It's a lot messier than that. Remember how we talked about explicit instruction is always a little messier with some modeling and more practice, or a lot of modeling and some practice. Same thing here. On any day, maybe you're going to need to pull in some hands-on tools. Maybe you're going to need to draw or ask students to draw some different things. And so really being prepared and understanding what tools are out there, what tools are going to help students with learning different math concepts and procedures, and pulling those in and also phasing them out as necessary. So it's important to think about those multiple representations, and those are really paired with our explicit instruction and precise language. And on this slide here, I put explicit instruction first because I'm never gonna just throw some manipulatives on the table and say, hey, let's go at it. You know, we're gonna use explicit instruction to demonstrate what these representations mean. And I'm also gonna focus on my language. I'm gonna talk about parts and a whole, or numerators and denominators, as I work on using these different representations. So with our instructional platform, we think about how we deliver instruction, and then we think about strategies to embed within our math intervention. And the two we'll focus on here today, pretty briefly, are building fluency, and then next we'll talk about problem solving. So with building fluency, we want to make sure that students have a strong understanding of the 4 operations. So by the end of 2nd grade, students should have a pretty strong understanding of addition and subtraction, and a typical expectation is that students have fluency with addition and subtraction facts by the end of 2nd grade. And by the end of 4th grade, the expectation pretty much across the United States is that students have a good understanding of multiplication and division, and strong fluency with the 190 multiplication and division facts by the end of 4th grade. But if some of you teach in middle school or high school, you've probably had the experience that I've had where I've met a lot of 6th and 7th graders that still really struggle with the basics of the operations, what these operations mean, and fluency with these facts. And so if you have some students that are experiencing difficulty with fact fluency, or maybe computation related to the 4 operations, we better put in some practice activities for students so that they can practice their fluency along with any of the bigger concepts that you're trying to teach within your intervention. So my typical rule of thumb is that if students do need fluency practice, it should be brief. Our typical fluency practice activities last 1 to 2 minutes, but it should occur every day. This is not a Friday only thing. It should occur every time you work with the student. And here are just some examples. I'm not promoting any of these. I just want to show you that there's a lot of ways to practice fluency out there. Here's an example of cover, copy, compare, or file folders is pretty similar to that. Taped problems is a nice brief activity to practice facts. Flashcards are really great, especially when paired with graphing, and you can do some self-regulation or self-monitoring there. You might do different activities. This is a magic squares activity where students place in the squares to create sets of addition and subtraction facts. They also have these for multiplication and division. You might just get out dice and have students roll those and multiply the 2 numbers together. There's wrap-ups and other different types of games, and also lots of technology available. And in fact, there's so many things, so many ways to practice fluency. There's really no excuse that you don't practice fluency with students. If you do use any technology programs, they should be tracking students' mastery so that students don't practice facts again and again that they already know. And it should also come up with ways to help students when they make a mistake. So what are some of the kind of like corrective feedback that's provided within the technology program? But again, this fluency practice, especially if it's with facts, just needs to be brief, but it does need to occur every time you think about providing math intervention. And then, and I'll stop right there. I don't want to get to word problem just yet. With fluency building, once students have a strong understanding of their facts, then you want to think about computation. So how efficiently do students add like 26 plus 37, or how efficiently do they divide 185 divided by 9? That's not fact knowledge, or that's not fluency. You don't memorize the answers to computation, but students should develop efficiency with that. Beyond computation, you might think about fluency with fractions, fluency with decimals, fluency with solving one-step linear equations. Really, fluency really never stops in mathematics. It's just, you know, you kind of go on to the next thing once students establish fluency in one area. Now, the last strategy that we want to bring in is thinking about problem-solving instruction. And this is really essential because most often when we ask students to show their competency in math, it is through solving word problems. That might be in your textbook, that might be on chapter tests or unit tests, that might be on benchmark tests that your school is administering, And that's definitely the case on high stakes assessments given at the end of the year. And so 3 things I'd like you to remember about this, about word problem solving, is that we don't want to teach word problem solving using keywords tied to operations. I'll give an example of why that's inefficient in just a minute. But instead, we want to teach students to have an attack strategy and to focus on understanding the word problem schemas. And both of those things that are in green have a very strong evidence base in both general education and special education. So this keywords thing, notice how I put an X across this. I hope nobody will screenshot this or take a picture of it and post it on Twitter. These are keyword posters, and they're in a lot of classrooms, and they are an inefficient tool for students to use. We just conducted an analysis of word problems, and for some types of single-step word problems, keywords work about 50% of the time. In other types of word problems, about 10% of the time. But for multi-step word problems, they work less than 9% of the time. And that's not a rate that I think is good enough to teach this strategy. With keywords, students look at these posters and they play a matching game between a word and an operation, but there is no single word in mathematics that means a specific operation. So we can't teach word problem solving like this, although it's the easier way to teach word problem solving. We also don't want to teach word problem solving like this. Notice on this page here, we say, hey, you're going to work on some subtraction problems. That's not really how word problem solving works in the real world. Students don't know whether they have to add, subtract, multiply, or divide. So activities like this, while it looks cute, are not really helpful and efficient for students. So instead, we need to teach students to have attack strategies. Here are 3, or here's actually 4 different attack strategies here. If you're in Texas, I just got an Amber alert, so I'm sorry, I was distracted by that. So notice on all these attack strategies, the first thing is to read the problem. Absolutely essential when it comes to word problem solving. Here's one of my favorite attack strategies. This is a copy made by a school district that I work with here in the state of Texas. UPS check. Read the problem by understanding it, make a plan, solve, and then check your work. All of us as adults have attack strategies. They're so internalized, we don't even realize we have it. But young children don't, and so we have to explicitly teach those. And then the other part of this word problem solving component is helping students recognize word problem schemas. Across the grades K through 8, there's really 6 schemas that we see with any type of regularity. Across grades K through 2, we see total difference and change problems. Introduced in grade 3, we see equal groups and comparison problems, and then usually introduced around grade 6 are ratios or proportions problems. So if you can teach students to recognize these structures or these schemas, and then they're able to say like, oh, that's a change problem. I know how to solve that. Maybe they have a graphic organizer or an equation that they use to solve it. It makes word problem solving a lot easier for students. So when it comes to word problem solving, please remember to not tie keywords to operations, but instead we should teach students to have an attack strategy and teach the word problem schemas. So as we put all of these together, those are our 5 very strong evidence-based practices that should be included in our instructional platform. So as we design math intervention for students, we start here and then we progress monitor, and then we make adaptations based on, do students need more of this, less of that? Do they need something a little bit different? But at the core, we should always be thinking about including these 5 components. So if you do want some more information about math intervention at the Meadows Center for Preventing Educational Risk, which is at the University of Texas at Austin, we've put together these 10 key documents. I know these were shared with all of you today. I hope that you'll read through these and share them with other math teachers or math administrators or anybody that's going to be focused on math. But they're really trying to put together what are the essential practices that we need to do in mathematics, and you will notice that all 5 things we talked about are included on both of these 10 key documents. I've also worked with the National Center on Intensive Intervention to put together a mathematics course. Here we have a lot of videos that you can watch or you can use in classes that you're teaching about how to design intensive intervention in mathematics. So if you go there, you're going to find hours of things about word problem solving, how to help students understand fractions, how to design interventions, so a better detailed thing about scoping, like we talked about at the very beginning of this webinar. So I hope you will access these materials and pursue them on your own. And then finally, I just want to thank the Council for Exceptional Children and the Institute of Education Sciences for putting on this webinar today. I'm really excited that so many people were interested to talk about math intervention. And again, if you want this presentation, it is placed on my website under the tab Presentations. And if you do have any questions or comments or want to talk math with me, I'm happy to talk with you. Please email me or find me on Twitter. And I will stop right there to allow just a few minutes for questions.
Great, thanks, Sarah. So we've got some good questions come in through the chat box already. If you have questions, feel free to type those in now, as many as we can.
Okay.
So questions we've gotten a lot of is related to resources.
Okay.
About that list of math terms associated for middle school and high school. Is that list available somewhere?
Yeah, I don't know if I'll get 100 emails, but if you email me, I can share our database with the 1,200 terms in it. And it has the grades K through 8 at the top. So then you can actually see like, oh, this term is introduced in 3rd grade, and then it's in 4th, 5th, 6th, and 7th grade. So then it can give you some idea of which terms are more important, which terms have staying power, and which terms might be like, oh, that's only in 2nd grade or that's only in 7th grade. So I'm happy to share that with anyone that wants that information.
Great, thank you. And then how about the 2 articles about the language of math? Where were those at again?
Yeah, so both of those were published in Teaching Exceptional Children. The first was authored primarily by Elizabeth Hughes in 2016, and that's an elementary focused one. And the second was authored by me in 2019. If you have access to those on the Teaching Exceptional Children website, great. If you need them, just email me and I will send the PDFs along to you. And I think that's one of the things I always tell lots of people is that if you ever see any research and you want it, email the original author and they will share the copies with you. Just legally, I cannot post those on like my own website because the copyright is held by Teaching Exceptional Children and not me at this point.
Great, thank you. Okay.
Welcome.
So here are a couple other ones.
All right.
Not linking keywords to operations.
Yeah.
Can you talk a little bit more about that and kind of the research behind it?
Yeah, so an example of this, I was in a 5th grade classroom last year where a teacher said, well, whenever you see share, that means you divide. And I later asked her, like, well, what happens if you made 50 brownies and you shared 10 of them? That doesn't mean that you are dividing. And so there is no specific word. Like if you see the word altogether, it does not mean you always add. Sometimes you might add, sometimes you might subtract. We also see altogether in a lot of multiplication problems. And so instead of teaching students to do that, we need to make them think about the problems at a deeper level. Now, I'm not saying that we shouldn't teach the key words. Like we have to talk a lot about altogether, and we have to talk about per or share or total. But then we also have to talk about, well, what else is going on in this word problem that is important for us to understand and digest. And so we have an article on this. It's under review right now. So reviewers are reviewing it and hopefully giving us feedback on it. We hope that it would get published pretty soon. But where we looked at the rate of keywords included in word problems and then how often that keyword, so if it said share and we kind of assumed share was a division word, how often that would help the student solve the word problem correctly. And that's where we saw that on average, they only, quote, worked about 30% of the time in single step word problems and less than 9% of the time in multi-step word problems. So teaching that to students is really an inefficient strategy and not something that we should do.
Great. Okay, we talked about brisk paces.
Okay.
I feel like you're leaving students behind. Why is a brisk pace important, and how can you kind of help those students who might not be quite up to that pace?
Yeah, that's a really good question, and this is really challenging because many times we're trying to keep students on grade level content as much as possible, but yet going back 1, 2, sometimes 3 or 4 grade levels to fill in some of those gaps. So when I say keeping a brisk pace, often I think about that as within the lesson, so like let's move along, and a lot of it is like organization. And many times students come to you for intervention. You might have them for 21 minutes. I would ideally like to see that they're doing math for 21 of those minutes. So do you have a warm-up activity out on the desks and ready to go as soon as they walk into your classroom? Maybe you go and pick up your students and you're walking down the hall. Maybe you play a math game as you go to intervention. So it's really maximizing the time that you have for students. And that comment just comes from, we get to do a lot of observations of teachers, and we see a lot of wasted time. We'll see an intervention session that's 25 minutes, yet the students only really did math for 17 of those minutes. And these are not the students where we can waste their time. We need to maximize the time. But if you see that, let's say you've introduced finding common denominators between 2 fractions, and your students are like, oh, I don't really get this, you need to do that next time. You might need to do that the time after. And so really realizing that your intervention is very dynamic. You might be like, okay, we're ready to move ahead. We need more practice here. And don't move ahead. That is what has happened in the general education classroom. And that is what has left a lot of these students behind. And so that's where intervention comes into play. You get to be dynamic and you get to review materials more. But you're as a teacher, you have to be very organized to keep up the pace within that lesson.
Great. Okay. We talked about a bunch of these questions I think you've already answered as we're coming in. What do you recommend for reinforcing vocabulary?
Well, so I think this is the most interesting question and has the least evidence base at this point. There was a really nice article by Paul Rigamini and his colleagues that came out in 2015 about the necessity to teach math vocabulary and some ways to go about it. And their strongest recommendation was to explicitly teach it. So that's, I think, where we are right now. There was a middle school study that I read pretty recently where they practiced, I think, about 8 or 10 math vocabulary terms with students. But again, it was explicit instruction and practice on the terms. But most of the time in our intervention, we explicitly introduce the terms, but then we use them over and over again, and the students use them over and over again. So for example, when we talk about word problems, we would talk about the difference between 2 amounts. And so I'll ask a student, well, what is the difference? And the student will say, the difference is 4. So they're reinforcing that language related to difference. I'm using it, and then they're talking with their students about difference. And so really at this point, because we don't have a lot of studies that have only looked at math vocabulary, most often math vocabulary is embedded within the intervention. So we don't know like what is the single best way to do it, but we know that it's important to include in our explicit instruction.
Great. Okay, we're right up on the end of our time. So a lot of the that are remaining are related to resources. I would strongly suggest checking out Dr. Powell's website, which you can see at the top. There is a screenshot.
Yeah, if you go to resources, I've got lots of links to some pretty nice teacher-focused resources. But then again, if you always want something else, please ask me. I'd also check out the What Works Clearinghouse, the National Center for Intensive Intervention. Those are 2 really strong places to go for resources as well.
All right, and with that, we'll go ahead and wrap up since we're right about 5 o'clock. Thank you all so much for joining us, and we'd especially like to thank Dr. Powell for sharing her time and expertise today, and our friends at IES NICSR, one of our lovely special ed abbreviations, for their collaboration on this. We are so excited to have partnered with them to bring you guys this webinar. For those of you asking, you will get an email later this week with information on accessing the webinar recording. I'll also include the link to Dr. Powell's website in there for you again as well. And with that, I will say goodbye. Thank you everyone so much for joining us. Thank you, Dr. Powell. Thank you, Nixer, and everyone have a great evening.
All right, thank you.
Bye, everyone.
Thank you.